Yeah, welcome everyone to our Hatchworks AI lab today. I'm Matt Page, VP of Strategy at Hatchworks AI, and I'm joined today by several smart folks. We got our CTO, Omar Shanti, and David Barrio, one of our senior AI ML engineers. And for context, Hatchworks AI is your AI and data transformation partner, helping you realize the value of AI through the power of your data. And today we're hitting on how to bridge the governance gap with data contracts on Databricks. And you may be thinking a couple of things right now, which, A, what are data contracts? We're going to cover that, so don't worry. And by the way, check out the latest episode of the Talking AI podcast we had on Andrew Jones, the father of data contracts. Really interesting discussion there. And then B, you may be thinking data governance is boring, unsexy. I want to talk about some AI. Well, if you want to do AI right, you have to have your data and more importantly, how you govern your data in order to truly take advantage of AI, all that AI has to offer. And that's exactly what we're going to show off today. And PS, if you're doing anything in AI, Databricks is an awesome platform you need to know about. And we're going to show off some cool stuff there, just like we do in every lab. We're going to actually show off some neat stuff that we've built. And with that, I'm going to kick it over to Omar, our CTO, to get us kicked off.
Fantastic, Matt. Thank you so much for that great intro. It's such an exciting time to be talking about data governance. And it really is an exciting time to be talking about everything related to data analytics, whether it comes to your storage solution, whether it comes to your ML, your dashboarding, or anything else. And I'm really excited to share some of the latest and greatest in both those fields. Data governance, specifically the concept of data contracts, which we'll do a little bit of a deep dive into. And I just want to underscore what Matt said. If you are looking to learn more, please do watch our episode with Andrew Jones, the father of data contracts, which is available on our Talking AI podcast. That was a lot of fun to record. And then secondly, we'll do a bit of a deep dive into Databricks. So we've made a few decisions along the way to really highlight some of the exciting features that Databricks offers. So grab your cup of tea, grab your cup of coffee, and get settled in for a nice conversation. I'm joined by the always amazing David Berrio Rios. He's a senior AI and ML engineer here at Hatchworks. Fantastic person to have on. Would you like to say hi, David, before we get started?
Hey, sure, very excited about this topic. Yeah, we're going to cover very cool things. So yeah, excited to what's coming.
Awesome. Yeah, friends of the show will recognize David, frequent contributor over here. David, correct me if I'm wrong, but you were last on one of these only a few weeks ago when we did a really cool demo around how you can use generative AI as part of your master data management. So Matt was mentioning that you can use, but that your AI is sort of bottlenecked by your data. But did you know that you can actually use AI to get your data in a condition where you can build AI projects on it? Well, if not, check out the previous webinar that David gave. And without further ado, let's dive in. So today's questions that we're going to be looking to answer are as follows. Firstly, what are data contracts and why are they used? You might have heard about data contracts, but never really understood what they mean or what the motive is. So hopefully this is for you. Second, what do they actually look like in theory and in practice? So it's well and good to have like this alignment on what a data contract might give us, but how do you actually bring it to your enterprise? And how does that change from small, medium, large? We'll give some introductory comments here and we'll show you in practice what they look like. But please use the Q&A to ask about your specific use case. And then third and final, how can I utilize data contracts on Databricks itself to enable reliable data self-service? Now, self-service is really the holy grail of enabling analytics across your organization, and data contracts and governance plays a key role in that, and specifically with the key word being reliability. If you enable data self-service without reliability, you risk having multiple sort of sources of truth, and you risk actually causing more confusion in your company. So reliability is key, and data contracts are a really important intervention there. So the problem statement we're going to be working with today is as follows. The lack of clear agreement on data management creates inefficiencies such as confusion and misalignment, and that causes sort of bottom line impacts to your business. Teams across the company to overcome this must agree on things such as the structure, the format, the meaning, and the delivery expectations of their data. This is all what I mean by data management, to truly break through their operational silos and unlock reliable enterprise-wide analytics. And what we hope to show you today is that data contracts are one way for you to bring those team agreements to your data management so that you can break through those inefficiencies and so that you can enable that reliable enterprise-wide analytics. So to frame our conversation, let's introduce a few personas. You're probably familiar with them. You've probably got them in your companies. You might even be one of them. Starting from left to right, we'll go from the application team all the way through to the sort of data-driven decision makers. So Lisa is an application developer. She lives in a competitive industry, so she has to move nimbly to ship new features that delight their customers in what's otherwise a very competitive market. Her team is responsible for building web apps and the microservices that power them. Her business is in getting and sort of creating these user experiences around users' data. So Lisa is constantly iterating, constantly shipping software. Now, Marco lives downstream of Lisa. Marco is a data engineer. His job is to take the data that is generated by Lisa's application and then ingest that into some form of analytical store, maybe a data lakehouse, as we'll see later on, for people to then run analytics on that. And that can be anywhere up and down the Gartner analytics ascendancy model. That can be sort of the what happened, the why did it happen, the what will happen next, and the how do we make what we want to happen happen. So as you go down there, you're moving from sort of the more statistical reporting to the more AI and ML use cases. Marco's job is to bring all of that data to enable answering all of those questions. However, the issue is, as Lisa changes her data model, as Lisa releases new features, she's actually modifying her data schema. And so Marco's pipelines keep breaking. And if Marco's pipelines are breaking, then he's constantly needing to ad hoc fix them. That makes it difficult for Marco to sort of forecast future work, to bring in more data, and so on. So Marco is sort of putting out fires, and the people downstream of him, such as Isabel, the BI analyst, need to work around that. Isabel's job here is for, as the BI analyst role, to create business dashboards and reports to enable data-driven decision-making, right? She surfaces up the insights that then allow people to make really crucial business strategic decisions. But she struggles. She struggles with inconsistent and incomplete data sets. She struggles when the data pipelines fail. She struggles with delayed data. And all of this leads to insights being delayed and additional inefficiencies, with Isabel needing to roll up her sleeves and do some firefighting work herself. And John is who this all bubbles up to. John is the data-driven decision maker. And if he receives unreliable data, then he risks operating under false assumptions. He risks making decisions based on the wrong signals. And not only does this jeopardize negative business outcomes, but this jeopardizes really strategic initiatives like AI and ML adoption at the very core. So
Where's that?
we'll come back to these personas. You go ahead, Matt.
Omar, I was gonna ask you, where's the shadow IT persona? Is it like hiding in the corner? Is that, I remember in like past life, that's where a lot of this breaks down. You have, people kind of doing their own thing off in these silos, and it just kind of wreaks havoc. And I feel like I knew the Marcos and the Lisas that were just like, cursing and all this stuff going on in the background.
Yeah, let's say that the shadow IT person has deleted themselves off of this slide, but they are secretly cursing us off the screen. All right, so these are our personas, and we will continue to come back to them. But so I want to introduce the concept now of data contracts, because data contracts will help all of these four personas sort of create agreements governing how they work together that de-risk their own delivery. So data contracts we can think about as formal agreements between data producers and data consumers. And these agreements define some of the things I was mentioning earlier: the structure, the quality, the expectations around delivery about the data, which ensures consistency, reliability, and clarity in the data exchanges across an organization. Now, you might think that the data producer is solely the application team, but that's not necessarily the case, because when it comes to, if we go back to the previous slide, when it comes to Isabel, she is consuming the data that has been compiled and produced by Marco, who had brought the data from Lisa and some of the other application developers, right? So just like Lisa is the data producer when it comes to Marco, Marco is the data producer when it comes to Isabel, and so on and so forth. So data contracts actually occur at multiple hops over here. We'll see what that looks like shortly as well. But to dive in a little bit more on what exactly a data contract looks like, I'd like to hark to the amazing work done by Bitol under the banner of the Linux Foundation in defining an open data contract standard, the ODCS. We don't need to really focus on the details here, but I'll use my cursor to point out here that a data contract will typically include a couple of things. It'll be a document that includes information such as the name, the version, and the descriptions of sort of the data artifact that the contract is capturing, as well as information about the schema, information about how quality should be assessed, and what governance policies there are when it comes to sort of remediating bad quality or shortcomings in quality, pricing if there's any chargebacks, the team involved with it, and SLAs. There are more attributes, of course, but what I wish to show is that under the umbrella of Bitol and this ODCS, we now have a fairly clear structure of what a data contract might look like. We have built on top of this ODCS v3. If you are not yet familiar, please do take a look because it really is amazing stuff. And we are looking to really highlight the amazing work that the team has been doing. So let's dive in. Let's talk about how data contracts help organizations. Now, just sort of articulating some of what we've called out previously, they help us define expectations clearly, right? We can align teams on the data structure, the format, and the delivery requirements upfront to avoid headache down the road. We can standardize data pipelines. We can ensure consistent and reliable data flow across systems and teams. There's no more data pipelines with very like data pipelines as a technology. There's so many different implementations, and some data pipelines can end up being hacky when they're done in silos. So data contracts can go some way towards standardizing pipelines, introducing a shared language for data quality, a shared language for annotation, shared language for sort of assessing the feasibility of data, and so on and so forth. It can reduce troubleshooting, accelerate collaboration, enhance data quality, as I mentioned, and also drive faster insights by giving predictable and usable data sets which are reliable. Again, that is the key word here. The challenges of not having data contracts, some of, again, what we've alluded to, miscommunication between teams, teams inadvertently using other teams' data schemas as agreements, when in reality, the team has never accepted that schema being an agreement. Teams want to move fast, so they like to have the right to change their sort of schemas. And so having this miscommunication can cause issues. Same with data quality. Over time, things happen. You get data drift, semantic issues change. So an address might evolve from being represented as just a street address to being a street with an apartment number and a zip code. There's increased debugging efforts as teams who understand the data less are working on figuring out why the pipelines are broken or why the data quality issues have gone awry. Delayed insights with some of these bottlenecks, and a general lack of accountability, a lot of sort of finger pointing and a lot of shrugging, saying, well, it was working when I gave it to you. So data contracts really come in to be proactive around handoffs, which is typically one of the things that we worry about the least when it comes to building sort of data pipelines. So I think I've talked enough. I'm gonna sort of set the stage for the demonstration, and then I'll kick it to David, and David will really run with it. So over the coming few minutes, we want to talk about how data contracts act as agreements between producers and consumers to define expectations. We want to showcase the data contract structure on ODCS 3.0, and we want to demonstrate proactive monitoring for schema drift and contract breaches. And we want to do all of this on Databricks, all the while showcasing the really amazing tech suite that they have, which I will just cover briefly. So Databricks as a data intelligence platform is sort of the father of this lakehouse architecture. Does amazing work. I mean, they bring compute and storage together so that you sort of can run your analytical workflows right there and then. That streamlines so much collaboration. Because it's cloud-based and it's very easily scalable, you can sort of make your bet and then run with it. And it's constantly using advanced automation and bringing AI to the edge. We'll take a look at some of the new features that have just been dropped, but using things like Genie and the Unity catalog, you're able to, in a way, get access to your data and conversational insights to your data right within the Databricks console. Hatchworks is a Databricks partner, so we are happy to sort of dive in more in depth if anyone's got any Q&A. With that, we will now talk about the architecture and dive into the demo. So David, I will pass it off to you, my friend.
Okay, Omar, thank you. So first, I know my volume was a bit high before, so let me know if it's any better now.
It's a little bit better, still a little high. I don't know if you can turn it down a little bit more, but
Okay,
uh
let me test. Yeah, how it sounds there.
still a little loud. Maybe just speak
Sounds
softly
okay
would
to
be
me.
okay. Yeah,
Okay,
is it maybe it's just on my side.
okay, okay. Well, yeah, thank you, Omar, for that amazing introduction. So yeah, now let's move from those concepts into a real case scenario. Uh, an hypothetical scenario where we're going to apply this concept of data contract for data governance, specifically using Databricks. So let's introduce a fictional company, which is Sports Analytics. So this company purpose is to gather and process different sports data to make it available for analytics and for different purposes like statistical analysis. Um, so this company has been growing a lot lately, and it's been an organic growth that has led them to several issues. One of them, they found that they have been facing a big bottleneck in data management. So since they are growing a lot, they are facing issues with data quality. They are finding difficult times trying to track issues in the data from upstream systems. So for trying to solve this inconvenience, they decided to go with a new data management and analytics provider, which in this case is Databricks. So basically with Databricks, they decided to implement a data lakehouse, and they decided along with that to start implementing the data contract approach to try to have a clear management of their data and have clear agreements on how data should flow from different layers of their system. So as we can see in the screen, we have three main layers or three different teams, I will call them, that are implicated like in the data flow from ingestion of the data all the way down to analytics and to reporting of the data. So the first team to the left is the application layer. So if you remember the personas that Omar introduced before, this is where Lisa is involved. So she's receiving data, storing that data into transactional databases or an OLTP database. Then that data that Lisa produces is being consumed by Marco, who is the data engineering working at the data lakehouse level. So this data lakehouse is structured following the well-known medallion architecture, which basically has bronze, silver, and gold layers. In this case, for simplicity of the demo, we drop the silver layer, yes, as Omar just mentioned in the chat, just for having a faster flow through this to this layer. But the idea is that we receive raw data in the bronze layer and we clean it and prepare it in the gold layer for analytics. And to the right, we have the analytics team, which is in charge of taking that data that Marco is preparing in the gold layer and transforming it into insights, into visualizations, into reportings that different stakeholders can consume. So that's the big solution that they decided to implement using Databricks and data contracts. Also, we can see in the data lakehouse layer that we have a quarantine table. This is used for storing data that is not compliant with data contracts, as we will see later in the demo. So yeah, let's jump in now. Now with this general overview, let's jump. I'm going to share my screen.
Now, just as the non-data gatherer, the quarantine layer, is that something that's with as a component or a concept within data contracts?
Yeah, usually it's not a part of data contract itself, but it's useful just in the data governance process when you have a data
Hmm.
contract to try to evaluate if some data is compliant with it. If you find some records are not compliant, you can have this kind of a structure just to move data that is not compliant with what you agreed in the
Compliant,
data
yeah.
contract. Yeah, exactly.
Cool.
So that's the idea. Okay, so let's jump in. This is the Databricks UI. So let's go back to our user personas. So this is, if you remember, we have Lisa, our application developer, This is what she sees every day. So here we have what we call our transactional schema, which is emulating the application database that we showed in the diagram before. So this can be in many real life scenarios outside of Databricks. This can be any transactional database. It can be Postgres. It can be SQL Server or whatever. In this case, because we want to highlight some Databricks functionalities, we decided to put everything together here. So this transactional schema is basically emulating what she and her team could be seeing in a day-to-day basis. So here we have the tables that she usually has. So this team is specialized, as I mentioned before, in gathering data from real matches of different sports. And in this case, we're going to focus on football, soccer data. So you will see that she has different tables. For example, let's jump into one of them. So this is the demo events table. And if you see, this is a cool feature from Databricks. This is brand new and is basically an AI suggestion description for your tables. In this case, I don't have a description for the table, but the AI engine is scanning what the table content is and is generating a description, which in this case is very accurate. So let's accept it. That's usually very, very useful. So as we can see, we have different kind of columns here. We have events, we have match IDs, event times. So let's jump into how this data looks like. So we can visualize how data looks like in this simple data tab, which will show us the first 100 records by default. So this basically is tracking different events that happen in different matches. So each event has an ID, is associated to a match, and has an event type, and is also associated to a player. Let's jump into another table just for visualization. So, for example, let's go to the teams table. So yeah, here we can see the different football, soccer teams that we have in our structure. So as I mentioned, this is a synthetic database for the demo. So we are using tech-related names like Warriors, Quantum Raptors, all this. So yeah, this is basically the data that Lisa team is handling and is storing in this transactional database. But as I mentioned before, the final goal of the company is not only to store this data, but to generate insights, analyze different statistics, and Lisa knows that this is not quite ready for that, and this is where Marco Teams comes into play. So if you remember, Marco is the data engineering in charge of the data engineering layer, and Marco knows that he needs to take this data and start processing it into a way where it's ready for analytics and for generating different insights or even for AI. So one thing that we discussed before that concerns Marco is that this data might change a lot, and if they don't have or they don't define a clear structure for this data, clear rules for this data, they might be having lots of issues with pipelines failing to process and having low quality data and this kind of issues. So they decide to define a data contract, which we're going to see now. So this
David,
is
did you use ChatGPT to come up with the football team names, or was that
yeah
straight from you?
yeah I did it came out with
Nice.
some cool names, so yeah, I like them. Okay, so Marco and Lisa start to work on this data contract, which, as Omar explained before, is nothing else than an agreement between two parties, one data producer and one data consumer. And this is how a data contract will look like following the ODCS 3.0 standard. So just for reference, this is basically the site where Bitol, which is the company in charge of this standard, stores all the documentation and provides all the details that you may need if you are interested into building data contracts following this standard. This is a good place to go so you can understand better how this works, how you should structure them, and what are like the different pieces of information that you need to consider when building a data contract like this one. So yeah, here we have a few of them. We don't have all the different files that we can add, but we have a few of them. We have like the headers or the metadata, which is basically what I'm highlighting here. We have a description of the data contract, which provides a purpose, limitation, usage. We have the schemas, which describes the schemas of the tables that this data contract is associated to. In this case, the transactional tables that we just saw. We also have some service level agreements, like in this case, the update frequency of this data. And we have also some quality rules, which are associated to different tables, different columns, and are descriptions of rules that the data should follow or conditions that the data should meet in order to be compliant with this agreement. So one beautiful thing to notice here is that we want this document to be easy to read. We want this document to be easy to follow. So if you see here, there are multiple ways actually to describe these rules based on the ODCS standard, but we decided to go with a natural way, a natural language approach to generate descriptions of the rules. So if you see, what we have here is natural language descriptions like ensure that event ID is unique and non-null, and so on. We have many of them, but in the end, for example, in this scenario, when Marco wants to ingest data from the transactional system into the bronze layer, he might need to find a way to evaluate that the data is compliant with this quality. Otherwise, he might want to send it to quarantine or send an advice to Lisa team or any kind of communication or raise hand like, hey, there's something wrong here. So to do that, nowadays, thanks of course to generative AI, Marco decided to create a Databricks job, which he named Route to SQL. And this job basically is running a notebook under the hood, which we are also going to see here. Second. Here it is. Okay, so we have a notebook here that is basically doing the job of transforming those rules, those quality rules that we defined in the data contract into SQL tests that he can programmatically use to validate the quality of data. So this approach is pretty cool because it allows us to keep separated the data contract from the programmatical details, because we want the data contract to be as readable as possible. So the good thing of this is that, as we can see, let's go back to the contract itself. Sorry. To the contract here, we have our descriptions in natural language, but after going to that pipeline, to that job of rule to SQL, what we're going to have is that we will get to a file like this, which basically is a JSON that has detailed SQL queries for each of the rules that can be used to validate and test the quality of data before ingestion. So this is very useful because we know that Databricks has some data quality rules tools inbuilt, but this approach is beautiful because it allows us to keep everything centralized into a data contract that is stored in natural language, that is transparent to everyone, to at least to both parties that are in part of this agreement, but also have this file detailing like, hey, how are we going to translate these rules into a programmatical SQL query that can help us validate those rules. So this is beautiful because this notebook, which is running inside this job, can be set up or configured to execute anytime a change is done on the contract file. So anytime a change goes into the contract, this job will execute. It will validate all the rules. If something is new, it will generate the SQL query and it will append it to this JSON that we have here. So now Marco, with this JSON, he can work on the ingestion pipeline to move the data from the transactional database into the bronze layer of the data lakehouse. So this is how that layer ingestion looks like. Basically, the ingestion from the transaction to the bronze layer. And this is what in Databricks we know as a delta life table, which is basically a process or an ETL that is moving data from one place to another, doing some transformations in between. Under the hood, this delta life table is also generating so it's also running a Python notebook under the hood that is basically using a Spark to move data from one place to another. So here basically we can configure many things on the delta life table. We can validate its execution. We can set different kind of triggers. This is very cool tool from Databricks that allow us to deal with different pipelines or transformations in a very, very flexible way. So after executing this bronze layer ingestion, what Marco will have is a bronze schema that looks like what we are seeing now on the screen. So if you remember, this is very similar to the transactional schema that Lisa had before, and this is by design. At this point, we are only ingesting the data into the data lakehouse. So let's take a look at something very cool here. So if you see, the demo events have been migrated, and since we used a delta life table to migrate this, Databricks provide us with this cool feature of data lineage that we can basically use to visualize how this data is flowing across all our systems. So the data is coming from the transactional schema demo events, is going into the bronze schema demo events, and then later we'll see that it goes to other places in the gold event. But this is all of this graph that I just showed, that's automatically created by Databricks when we use delta life tables as the ETL method to move data around. Okay, so after this,
David, just a quick question, please. So
sure.
a comment, and then I want to ask Atish's question. Now, it's amazing. Like we've sort of gone seamlessly from looking at governance through lineage, through observability, through sort of storage, and it's all under one umbrella, right? And when we run our data quality tools, we're actually seeing built-in IDEs as well. So it's just really fascinating how everything is under one umbrella and seamlessly integrates with each other. Now, the question is from Atish, whether the results from our data quality runs are actually stored in a data set for analysis, for analysis, dashboarding, etc. I will speak to the fact that that is the best practice in general, Atish, because that allows us to sort of go back and say, here's how we performed against our SLA. So if you think about this data as a product, you want to have product metrics and understanding, you know, the data quality runs, things like the data freshness, the latency, and figuring out where the data quality shortcomings are is all really important. Some bits of data quality are worth more to a business than others, for example. You know, alert fatigue is a big challenge. And so for all of those reasons, I think the best practice is definitely to store them. Now, question, David, have we stored them as part of this POC, or did we just decide that it wasn't the most important thing to prove, so we didn't store them?
So in this case, particularly, we're storing, as we saw before, we have this demo event server, and I don't know if this answers the question, but for data quality issues that we find in the bronze pipeline ingestion, we quarantine all of them in the demo event server, which is another table inside the bronze schema. And this table not only stores the event data as it was stored in the transactional schema, but also generates different error messages that will allow us later to basically query and understand how that migration is working, and if we have multiple errors, which kind of errors we have in this quarantine table. I don't know if this is aligned with what you were asking in this case, but this could be a good approach to validate how our pipelines are executing. Of course, the pipeline itself, when it executes, it allows us to configure notifications that are automatically sent in case any error is detected, and we can be very flexible with that as long as we know what kind of error events we want to control.
Well said. So then I guess if I can just read that back, I think the idea is that we've got fairly unlimited freedom here. We can store for the product metrics that I was talking about earlier.
Yep.
So we can sort of build like a meta dashboard talking about our data quality and so on.
Absolutely.
Something like this would naturally sort of bubble up into somewhere like the Unity catalog, which is, the data catalog or either the metadata catalog. Additionally, this can be used to sort of trigger retraining of models. So if data quality is like under a certain level, or if data drift has been detected, to trigger a retraining of models, or to trigger some form of action. So a data contract is great, but it needs to be enforced. And having these data-based signals trigger an action is one way of enforcing them. So yeah, really great question.
Absolutely. Definitely. That's very important. Enforcement of this contract is key. And that's part, in this case, of the ingestion pipeline. And that's why we took care of generating those SQL tests before executing the ingestion pipeline, so we could have them in order to enforce the data contract and try to understand how things are moving around. Okay, so now we were talking about the bronze schema, and we know that we also have the gold layer schema in the diagram that we presented before. So under the hood, there's another delta life table that is in charge of mapping the data in our bronze schema into this gold layer schema, which is a schema more designed for analytics. So here we're going to have a single table which has lots of aggregations. In this case, the table is not event-wise, but match-wise, which might be more useful for some types of analytics. So we create what we call the matches fact, which is basically this gold layer table that we are that Marco team will provide later to the analytics team on Isabella's side. So we're not going to get into that detail here, but there's another delta life table running under the hood here and mapping the information from the bronze schema into this gold matches fact table. So again, we can easily take a look at the lineage of data here, and we can see that our gold schema table is fed from these three tables on the bronze schema. In this case, demo events, demo players, and demo matches. So this is beautiful because it can easily tell us, hey, the data that we have here is coming from these upstream system tables, and we can have transparency on that part. So yeah, now that we are here, this data in the gold layer schema is what the Isabella team, which is the team in charge of analytics, of generating insights for the stakeholders, will consume. So as you can see here again, we have a new agreement between two different teams. So in this case, the Marcos data engineering team is going to be a data producer that is producing this table in the gold layer, and Isabella team is going to be the new consumer that is going to be consuming this data in the gold layer. So for that, again, Marco and Isabella decided to define a new data contract, again following ODCS standard 3.0. So very similar structure to what we described before. Very similar items. So we have a description, we have a schema, we have a service level agreements, and we have some data quality rules. So again, this will allow Isabella to have a clear conditions on how is the data that she will be consuming from the gold layer in order to create the reports that she will be generating for different stakeholders, or even how this data is used to train different machine learning models. And as Omar mentioned, she can understand how that data is changing, and if there are issues when integrating that data from the Go layer into these analytic systems. And yeah, she can easily track for different things like model drifting. She can track for alerts that can tell her like, hey, we need to retrain this model because data is changing. The way we are going to be receiving data from the gold layer is changing. So this will set some clear rules for them to play and have a better communication and make them accountable for the way they are providing data on each of the sites. So yeah, now that Isabella team is able to connect to this goal layer data following these data contract rules, she's able to do cool things like generating dashboards. So Databricks has inbuilt dashboards creation capabilities. So in this case, these are just a few examples of this. This is a very powerful tool and super intuitive because it's also powered by Genie AI. So you can create diagrams or charts by hand, but you can also easily ask Genie AI to generate something for you. So let's ask, for example, like create a graph with total goals per team. So this is a very cool feature because it basically connects to the goal layer. In this case, you can input a prompt and it will generate using that data from that table or that schema that you provide to Jenny. It will generate a table that fits your requirements. So this is a pretty cool tool, very usable. So this is something that Isabella team is constantly using, and having a data contract in between the goal layer and this analytic team gives her confidence that this data is compliant with quality rules and gives her clear rules of refreshness and yeah, basically how she should be consuming this data. Also, along with creating dashboards and visualizations, Isabella team also has access to Genie AI a chatbot, which in this case works very similar to what we just saw, but in a conversational interface. So this allows you to set up a chatbot and point to some tables into any of your schemas in the Unity catalog in Databricks, and you can generate any question. So for example, in this case, what is the average amount of goals done across matches? So let's ask this and see, let's see what Jenny give us. So this is very cool because it provides an answer in natural language, but it allows you to do several things. So for example, you can see the code that it's using under the hood to generate the query that answers your question. So you can validate if what you are seeing is actually calculated correctly. So there's a lot of transparency here. Also, depending on the question that you ask, you can generate a different kind of charts as well in this tool. You can generate bar charts, line charts. Yeah, this is basically a layer of interaction with data that goes one step beyond just text to SQL, which is what we usually do to transform a question to an SQL statement like this one. I think this goes a step beyond because it allows you to not only generate queries, but also generate visualizations, and yeah, basically deep dive into your data using natural language. So this is a pretty cool feature that a team like Isabella's team could get a lot of benefit from. So yeah, this is basically the whole flow of data that we wanted to show and how data contracts helps having a clear expectation, have better governance on this data, and how Databricks enables some very cool tools that allow us to integrate those contracts and to generate pipelines that move data around in a very easy way. So yeah, any comments or questions?
Yeah, just on this AI BI Genie, I was at the Databricks World Tour conference here in Atlanta. Was it last week? I can't remember, but it's really cool. Like you can provide feedback on the queries you're providing. You can set up like individual, like I forget what they call them, like rooms or projects for specific groups that have access to specific data. You can kind of do this testing around, common questions that get asked. And, if you're asking about XYZ, you want it to kind of always, go in this type of format. So there's a lot of neat functionality they're building around this, which at the end of the day, it's just kind of democratizing access to data. 'Cause I know, like I used to be in this seat where somebody would come and ask you for a question. You develop the SQL query, which would then trigger another question, which would require another ticket to be put in to then go adjust the query. It's this like vicious cycle where this just kind of empowers the end user, which I forget the name of the persona we had, but just to like ask questions of the data. It's really cool.
All right, gents, unfortunately, I do need to hop off, so I will leave you both in very good hands. I'll leave the audience in
Thanks,
very good
Omar.
hands.
Yeah, it's late. It's late where
will
you are. We
see-
appreciate it. If there's any other
I would
questions,
say I've
feel
just
free
got a
to.
contract, unfortunately. Yes.
Yeah, no worries. Yeah, but if any other questions, feel free to reach out to us. And you can find us on LinkedIn or just go to hatchworks.com. You can drop us a note there. And I think we covered most of the questions. But yeah, if you got any others, let us know. We'll share the recording as well if you want to check this out or share it with anybody else. And have a great Thursday, everybody. Thanks, David.
Okay, thanks a lot.